Little bit of glare action, but it's all right. All right. So again, like dissolves like. Memorize that. Polar dissolves in polar. You just saw it back there. Iodine dissolves in ethanol because ethanol has non-polar properties, but it didn't dissolve in water. Water's polar. Okay. So, but what about ionic? Ionics will dissolve in water. So what? I put a star. It's like what's going on with that, right? I want you guys to
like just water.
No, there's other polar substances too. And I want you guys to try and figure that out. Here as a class, we can talk about it. But actually, one thing that just popped in my head about our list of properties. I just wanted to give an example of the melting points. What does water melt at?
0.
Right, 0. Right, ice. If I was holding ice, it would melt in my hand. Right? Okay. What about salt? Can I melt salt in my hand? No. Salt is ionic. Water is covalent. Salt melts at 801 degrees Celsius. That's a huge difference. So when we wrote ionic have high melting points and covalent low, it's like not even close. Okay, these are way stronger. And again, the example, 0 degrees versus 800. Huge difference. Just wanted to throw that out there. However, there is a whole spectrum. Sugar, for example, has a much higher melting point than water, but still a lot lower than salt. You can't melt salt on your stove. You can melt sugar. So that's just another example. All right, anyways, back to this. So the reason polar dissolves in polar and nonpolar dissolves in nonpolar is they have something in common. It's their forces and their bonds. So here's my analogy. Usually, your closest friends, your group of friends, people you hang out with, usually people do that and they form groups because they have something in common with them. It may not be exactly the same, but you do something you'd like to do, like play sports or you're in the musical or whatever. You have similar hobbies that you enjoy doing together, right? There's a reason people have, close friends with this person, but you're not close friends with this person. And that's okay, that's normal, that's human nature. So the analogy is, chemicals are the same way. Polar doesn't want to hang out with nonpolar, they have nothing in common. But they will have something in common with other polar molecules because they're very similar. So the reason I use the analogy is what's going on here. Why are these two willing to hang out? What do they have in common, even though this is ionic and this is covalent? So two different types of bonds, but how come they mix? So now, that's on you guys.
Because chemistry is
Symmetrical.
something.
So I'll just say it again real quick. These two, so if you take H2O and NH3, ammonia and water, they mix very well because they have a lot in common. Again, the analogy, like to hang out with each other because they're similar. Same thing here. Iodine and alcohol, very similar. They're both nonpolar. My question to you guys, why, even though these are two separate bonds, covalent and ionic, very different, why will they mix and dissolve? What do they have in common? Because they only dissolve because they have something in common.
The difference in between solids.
You're getting closer. It's about how they're put together.
They're asymmetrical.
Symmetrical.
Yes, there. Think about
Polar.
think about this, right? And then think about this. What puts this together, or what holds it together? What's salt made of? Don't say salt. Ions, right? It's made of Na plus, Cl minus. What's going on over here?
Partial positive, partial negatives.
It's the partial negative, partial positives that are actually attracted to these charges. So the negative Cl is attracted to the partial positive hydrogens, and the positive Na is attracted to the partial negative oxygen. That's the only reason ionics and salt, for example, dissolve in water. So when you go make salt water, right, whatever, you got a sore throat, want to gargle some salt water, the only reason it works is because of this. There's ions in the salt that's attracted to the partial charges of water. If water wasn't polar, wouldn't work. Wouldn't work. Water being polar is the reason, this is going to sound ridiculous, but the reason we're humans. All right, is because water is such an important part of Earth and us. It's because it's polar. If water wasn't polar, our species would be completely different. We wouldn't really be considered humans. Okay, so I know that's kind of crazy, you know, and I'm recording this, so someone could watch and think I'm like out of my mind. But the point is the fact that those hydrogens. This is why I like chemistry and science. If these hydrogens just were a little different, life would be completely different for everything on this planet. So the fact that hydrogen's bent a little bit changes all the properties of it. To me, that's cool. I find that cool. So that's why salt can dissolve in water. Okay. All right. So I need you to write that down. The salt, the ions. Write this down. Then we're done. Ions are attracted to partial charges. So last statement here. Then we're good. So like dissolves like means something is in common. This is what they have in common, those charges and partial charges. That's what they have in common. Alright? And I'm basically out of time anyway. So unfortunately no homework.
Yes.
I have a sheet about this somewhere. I just couldn't find it.
No.
I didn't copy it, so.
It's a little late now. So.